Time is a concept that permeates every aspect of our lives. We schedule our days, plan for the future, and reminisce about the past, all guided by the relentless ticking of the clock. But what if I told you that time, as we perceive it, might be nothing more than an illusion? The notion that time is an immutable, linear progression from past to present to future is deeply ingrained in our collective consciousness. However, as we explore the realms of physics, philosophy, and neuroscience, a fascinating picture emerges, one that challenges our intuitive understanding of time and suggests that it might be far more elusive than we ever imagined. The way most of us perceive time is rooted in the concept of the arrow of time. This arrow points in one direction, from the past to the present and into the future, creating an unbroken linearity. We experience events as occurring in a fixed order, where the past causes the present, and the present causes the future. Our daily routines, from catching the morning train to celebrating birthdays, rely on the idea that time flows inexorably and unidirectionally. It seems like an incontrovertible truth, but as we delve deeper into science, we begin to glimpse the cracks in this seemingly seamless illusion. One of the most groundbreaking insights into the nature of time came from Albert Einstein's theory of relativity. According to special relativity, time is not an absolute, universal constant but rather a relative and malleable concept. Einstein proposed that the fabric of spacetime is curved by massive objects, creating what we perceive as gravity. In this framework, time flows differently in regions of varying gravitational strength. A vivid example of this phenomenon is the famous twin paradox. Imagine one twin embarking on a journey through space at near the speed of light while the other remains on Earth. When the space-traveling twin returns, they find that less time has passed for them compared to their twin on Earth. This demonstrates that time dilation is real, and the rate at which time passes is relative, dependent on factors like velocity and gravity. General relativity extends this idea by introducing the concept of spacetime as a four-dimensional continuum where massive objects warp both space and time. It suggests that time can be bent and distorted just like space, challenging our intuition that it flows uniformly and predictably. If general and special relativity challenged our understanding of time, quantum mechanics takes us even further into the rabbit hole. In the quantum world, the notion of past, present, and future becomes highly ambiguous. According to quantum theory, particles at the subatomic level can exist in a superposition of multiple states until observed. This leads to the famous thought experiment called Schrödinger's cat, where a cat is simultaneously alive and dead until observed. This apparent timelessness at the quantum level calls into question the very foundation of time as an unbroken progression. It suggests that time may not be an inherent property of the universe, but rather a product of our observations and measurements. Furthermore, the phenomenon of quantum entanglement, where particles can instantaneously affect each other's states regardless of the distance separating them, raises questions about the fundamental nature of time and causality. Could it be that the flow of time is an emergent property of the interactions between particles rather than a fundamental aspect of reality? Another intriguing concept that challenges our conventional view of time is the block universe hypothesis. According to this idea, the past, present, and future all exist simultaneously as an unchanging four-dimensional block. In this view, time is merely a dimension, much like space, and our perception of the passage of time is an illusion. Imagine the universe as a vast library, with each book representing a moment in time. From our limited perspective, we can only read one page at a time, giving us the illusion of a linear narrative. However, the entire library, with all its pages, exists concurrently, and there is no objective now. Advocates of the block universe argue that this perspective is more in line with the laws of physics, as it accommodates both relativity and quantum mechanics without the need for a unique, ever-moving present moment. From this standpoint, the flow of time is an illusion created by our conscious perception, and the past, present, and future coexist in an eternal now. While the theories of relativity, quantum mechanics, and the block universe offer profound insights into the nature of time, there is another layer to this enigma: the role of the human mind. Our perception of time is intimately tied to our consciousness, and it can be influenced by various psychological and neurological factors. Psychologists have long studied the phenomenon of time dilation, where time appears to pass at different rates under different circumstances. Moments of intense focus or exhilaration can make time seem to stretch, while periods of boredom can make it drag. This subjective experience of time hints at the malleability of our perception. Neuroscientists have also delved into the neural mechanisms underlying our sense of time. The brain has a complex network dedicated to processing temporal information, and studies have shown that alterations in this network can lead to distorted perceptions of time. Conditions like schizophrenia and certain neurological disorders can disrupt the normal flow of time perception, further highlighting the role of the mind in shaping our experience of time. The illusion of time is a multifaceted and deeply philosophical topic that transcends the boundaries of science and philosophy. It challenges our intuitive understanding of reality and forces us to grapple with the profound implications of our perception. From Einstein's relativity theories to the strange world of quantum mechanics and the concept of the block universe, our exploration of time leads us to a paradoxical conclusion: the very thing we hold dear, the inexorable march of time, might be a construct of our consciousness rather than a fundamental aspect of the universe. As we continue to unravel the mysteries of time, we may find that our understanding evolves even further, blurring the line between science and philosophy. The illusion of time is a reminder that our reality is far more complex and enigmatic than we can ever fully comprehend, inviting us to question our assumptions and explore the profound depths of the universe and our own minds. In doing so, we may discover that the illusion of time holds the key to unlocking some of the deepest secrets of existence.